Hey everybody, here we are again. Guess who's here? Yup, you guessed it. It's Mr. Eiler. Alrighty, today what we're going to talk about is motion graphs. So up till now, what we've done is we worked on making motion diagrams. Now we have to switch over to graphs. Now this is huge, and kids kind of have a tough time with this sometimes. So let's not go too fast. Let's see if we can get it. Alrighty, motion diagrams to motion graphs. Let's start out and make a motion diagram of someone just walking at a steady pace. Okay, so I want you to imagine the pictures in your head. I'm not going to draw those. I'm going to jump immediately to a dot diagram. All right? So here we go. I'm going to put a dot here. It's our first dot. And we're going to go here. Try to make them evenly spaced so we can say the speed stays the same. Not speeding up or slowing down. All right. On the top, let's put the times. We're going to go time equals 0, 1, 2, 3, 4, and 5. And let's do seconds. Okay. Now let's put a scale on there. I'm going to try something new here, see if I can get this to draw a perfectly straight line underneath. Look at that. That's pretty cool. And now I'll see if I can put a scale on it. We'll put 0 right there. And then I'm just going to try to make these even as we go across. All right. How am I doing? And we'll call this 0 meters. Whoops. Sorry about that. We'll call this 0 meters. 1, 2, 3, 4, 5, 6, 7, 8 meters. All right, there's my dot diagram with the distance put on it. Let's take that and we're going to change that now into a motion graph. Okay, so here's what we're going to do. I'm going to move that all the way up to the very top, as high as I can get it. A little too far. Let's do that. Now let me make a big graph here. You know what? I'm going to see if I can draw straight lines again. I'll try that little fancy tool I just did. See how that works. Hey, look at me. That's pretty good. All right. So there's my axes. Now, remember on the bottom, we're going to put time. And on the vertical axis, we're going to put position. Okay? I'm going to write position. And I'm also going to put X. So we know that we're dealing with X. We'll put a parenthesis around time as well. Probably not quite right. How far do we have to go with time out here? Well, our graph goes out to 5 seconds. So let's put 0 here. And I think they'll fit if we make them about that far apart. How's that? I got a little squinchy at the end. That's close though. All right, see if you can do a little better on your paper. Time, or position, I'm sorry, goes up to 8. So those will be a little closer together. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. We're going to stop. We can figure out the rest. All right. So there we go. Now, let's do this. We're going to put dots on this graph for our motion up there. I'm going to put the dots in blue, I think. All right. At 0 time, what is the position of our person walking? Okay, at 0 time, times the blue numbers at the top, what's the position? It's 0. Easy enough. Let's put a dot right there. Okay, at time equals 1 second, where are we? Looks to me like we're at about 1.5. So go over to 1 second, go up to 1.5 and put a dot. All right, I want you to fill in the rest. Pause me. I want you to work ahead and then start me off. Alrighty, hope you got them all. All right, looks to me like at 2 seconds we got 3. I'm going to try to match these up. 4 seconds we have about 6. This wasn't too even, was it? And at 5 seconds we're at about 8. So there's my dots. Okay, how did we do? Let's connect those with a line, because what we know in this case is whoever was doing the walking walked in between these 2 points, or between all these points, right? So we should be able to draw a straight line straight through all of them, pretty close. That's not too bad. I did the fancy line thing, so it would be a perfectly straight line. All right. Now, my dots didn't line up perfectly. If I had measured perfectly and drawn perfectly, we'd have an absolutely straight line. Now, very important. Here's what we just did. I described in words to you what happened. We drew a motion diagram. Okay. Even skipping a step, we didn't even draw the pictures. Then we took that diagram and we made a graph out of it. All right. So we're taking baby steps here, and this may seem a little slow, but we're going to be flying across this stuff really quickly. All right? So let's move on. Let's go a little faster now. Let's do one where someone walks just like before, but then they stop and they stand for a little while, and then they start walking again. Okay, now I want you to jump to the motion diagram, the dot diagram, and then draw the graph. Okay, go ahead and give that a try. What I'm going to do is I'm going to skip right to the graph, and I'm just going to draw the shape of the graph that you should have. So pause me and then start me back up when you're done. All right, I'm going to work on my graph here. So I'm going to cheat since I'm the teacher. All right. And we're going to go put X here and time here. And now I'm going to draw just the shape that you should have. So what we should do, the graph should go up at some angle. It should stop. Then when that person is not moving, when they were just standing still, your line should be perfectly flat. Time is still going forward, but the position is staying the same. Can you see that? Now, when they start walking again, let's pretend they go at exactly the same speed. That line should be tipped just the same as the other one. Now, what I hope is your graph is fancier. You have the tick marks on the bottom and on the side, and you've done the measurements, and it lines up well. But the shape is really, really important. Did you do okay? I hope so. Hope things went well. Now, let's do one more thing. Let's do something really cool with the graph. All right? Now, let's go back to a little math review. We're going to do our math review in blue. Okay? And here's what we're going to do. Do you remember what the velocity was? We're going to use this so much you're not ever going to forget it, I don't think. It's going to be delta x over delta t, the change in position over the change in time, or the displacement over the time. All right, and this is going to be the final position subtracting the initial position. Notice I used a little f for final and an I for initial, and we're going to do this final time minus the initial time. All right, now what I want to do is we're going to go back to that first graph we made. I'm going to skip back a couple slides to this one. All right, and I'm going to see if I can do something really fancy. I'm going to try to grab this whole graph and everything I did on it and make it one thing. We're going to group it all together. Then I'm going to take it and I'm going to duplicate it wherever it is. We're going to copy it and we're going to paste it right over here in this area, if I can figure out how to do that. Let me go back and try one more time. Oh, clone it. That's what I wanted to do. I wanted to make a second one. So there's two there, and I'm going to drag one right over here. Sorry. Now I grabbed one, and we're putting it right in the slide where we were at. All right, it's down a little low. It's right here. So now notice, I'm going to grab it. There we go. Sorry about that. And pull it right up here. Now check out what we can do. Velocity is the change in x over the change in t. All right? So let's pick two spots. All right? Watch, which ones do we want to do? Do we want to, let's just pick, I don't even know. Let's pick 0 and 4. Okay? So here's what we're going to do. We're going to do x at time equals 4. We're going to subtract x at time equals 0. And then we're going to do the same thing with the time. All right? So first of all, let's find the position where x equals 4 seconds. So if we go 4 seconds and we go straight up till we hit the graph, we go hit right there. Now let's go across. Where do we get? Right to there. Alrighty? So we went from this spot here, 0 and 0, up to 4 seconds. All right? Now check this out. This is really cool. Let's fill in the numbers. I'm just going to move right down. The position at 4 is about 6.5. Can you find that on the graph? The position at 0 is 0. The time at t equals 4 is 4 seconds. That's hopefully a little bit obvious. Minus 0. So now we have 6.5 divided by 4. 4 goes into 6 once. 25 is left over. 4 times 6 is 24. So that's about 16 point something. All right? I'm going to put a little squiggle above my equal sign to say about. 16, and the top is in meters, the bottom is in seconds. So our velocity is 16 meters per second. But I just goofed. It's not 16. I'm so sorry. It's 1.6. Did anybody catch me on that one? 1.6 meters per second. Now, check this out. That has too many sig figs. Notice what our initial numbers had. It was 4. So we really should go about 2 meters per second. I'm going to leave that for now, knowing that it's wrong. But here's the deal. Here's the big idea I wanted you to see. When we did this whole thing, the velocity is just the same as the rise over the run. Anybody remember what that is? Doo 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 doo! The velocity of a position and time graph is the slope. Okay? So this one's easy. The slope stays the same and the velocity stayed the same. If the slope changes, that means the velocity is changing. Okay? Little tricky. Let's see how you do with our problem. Here's our homework problem. Have at it. Hope you enjoy. Thanks for coming. Bye-bye.